higher flops you want to test, then you need more time. It's taking computer resources when maybe you're close to tape out and everybody is struggling to get some machine and license. And this is internal in-house solution that only big companies, maybe like Intel and IBM or maybe others, they can build. You need to develop this kind of software to collect the results from hundreds of thousands of simulation and collect them into a report and so on. So it's very, it's hard solution. And you're still doing low sample rate. You're not testing all cycles. And what is the cost of doing low sample rate is you have to do low sample rate to finish in reasonable time, 3 to 4 weeks. But what is the price? Is that we are getting less accurate report than if you do full sample. You may get flop. You may discover that it is not soft error sensitive, while it is. So you are not hardening the flop that should be hardened. It can be the opposite. You can be hardening flops that you thought they are sensitive while they are not. So the accuracy you can pay for the lower accuracy by silicon and by lower reliability. Lastly, I want to talk about our tool. One slide.
4 weeks. What size of the design?
Let's do big chips. We're talking about big chips. This side. I mean, we're not talking. I don't know. But I mean, you can calculate yourself. You take your own simulation. One simulation takes, let's say, 5 minutes for normal run. You multiply this by the number of flops by the number of cycles. So it's huge. So what our tool does is this. It does the flip-flop selection. It's a method very similar to the error injection that we discussed, but it's done in a more optimal way. It takes the RTL here. It takes the RTL or the gate level. It takes information about your fit information about the libraries, the flops that you are using, and so on. User give us some input, and based on this, we generate the SUS report. See that? SUS report is saying you per flop, what is the probability of this flop? If it's hit, it will cause a soft error. Then this goes into Cosmic Analyzer, where you make your trade-off decisions. You choose between higher reliability, lower reliability, you want to pay more silicon, and so on. Once you make your decisions, we will generate ECO file, which will tell the backend which flops should be hardened and which should not. This process is at least 1,000 times faster than simulation. That's what we have so far. Plug-and-play solution doesn't need a lot of work from the user. And maybe 100% accuracy is maybe too much, but it's much more accurate than the current methods. In summary, so soft error problem is strengthening. It is becoming more a problem of the present. Mitigation technique exists, but they cost a lot of silicon, power, NRE, per chip cost. Flip-flop selection is a must, and we discussed the Cosmic ASIC as a solution for the problem. And you're invited to visit us at booth A03 if you want more details. Any questions? Do you have time? Questions? Okay. Thank you.
So that we have already selling the tool. So what is the user experience you're getting?
We are starting alpha, not selling. I can tell you what the user experience will be when we are selling. It will be should be very easy to use. You read in the RTL, you enter some information about areas in the chip that it's.
So Tuvia was an alpha customer?
No, it's not a customer yet. We just talked. Okay, thank you.